So what is the turning effect of the force or a moment? So basically, when we apply the force on the object, you can also say moment or you can also say torque. Torque or moment having the same meaning. What is the concept of the moment? What is the concept of the moment, the turning effect? So when force is applied on the object and the object rotate. So what we call that as moment. Example, you have an object which is fixed from one end. This is a point where the object is fixed. The point where the object is fixed, that is called pivot or pivot, or you can also say fulcrum. And if we apply a force on this object, example, if I apply an upward force, so what I will observe when I apply upward force to an object which is fixed from one end, so observation is that the new position, this object will change its position. So new position of object. So object will rotate and this will be the new position of object. So as the object rotate, by applying a force or turning effect of the force, we call that as moment. Which direction this object is rotating, clockwise or anti-clockwise?
Anti-clockwise.
So this object is rotating anti-clockwise, opposite to direction of the clock rotation. So it's having a direction. Whenever any quantity is having a direction, what we call that quantity as a vector quantity. But what are the directions here? In this case, the direction of the moment or torque, it can be clockwise or it can be anti-clockwise. So the object, the point where the object is fixed, that is called pivot or a fulcrum. And to calculate this moment, if you want to calculate this moment, how we calculate? Torque or momentum having a same meaning. Moment, sorry, not momentum. Moment, I can say moment or I can also say torque. What is the meaning of moment or the torque? It is a turning effect of the effect of force. So when force is applied on the object and the object rotate, we simply call that as moment or we call that as torque. So when we apply force, object can rotate clockwise or object can rotate anti-clockwise. So example, there is a definition, turning effect of the force about a pivot is called a moment. And everyday example, like example, when you're opening a door, so opening a door is also example of moment, because as you apply force on the door, the door will rotate. And what is a pivot for a door? Fulcrum or the pivot, the point where the object is fixed, that is called fulcrum or pivot. So the door is fixed from one end, hinges are there, and the other side you have a knob. This is a door knob. So when you apply force, on this door, what you observe the door rotate. So whenever you apply force and the object rotate, we call that as moment, the turning effect of the force. And moment can be clockwise or it can be anti-clockwise. Is it clear, the definition of the moment, the concept and the definition of the moment? Then how we can calculate this moment practically if you want to calculate the moment or the turning effect? These are some more examples like loosening or tightening a nut using a spanner or a wrench. That's also because if you want to lose or tight a nut, you will apply a force and the object will rotate. So whenever rotation is there, we always call a moment. Lifting a load with a wheelbarrow also. These are few examples of moment. Shooting a ball is momentum, not moment. Whenever object rotate by applying a force, object is fixed from one end and it rotates around that point, we call that as moment. When object is moving, it is having mass and velocity, we call that as momentum. So how we can calculate a moment of a force? If you want to calculate a moment of the force, so to calculate the moment of the force, we need force multiplied by perpendicular distance. So example, if we have an object, say this is an object, and this object is fixed from one end. This is a point where the object is fixed. The point where the object is fixed, that point is known as pivot. So we apply the force on this object. So what we will observe, when we apply force on the object rotates. Which direction this object is rotating, clockwise or anti-clockwise?
Boys.
Point where the object is fixed, this is anti-clockwise. Point around which object can rotate, that's called pivot. So if you have any object which is fixed from one end, the point around which the object can rotate, because what will happen if I say this is an object is fixed from one end. And when you apply the force, example, you are applying force in this direction. So what happened, the object, this whole object can rotate about the fixed point. This point will not move, all the points, the object will rotate. The point which is not moving or stationary or object move around that point, that is refers to pivot or fulcrum. So if you want to calculate the moment, so to calculate the moment, it's force multiplied by perpendicular distance. Is it clear? The difference between the moment and the momentum, if you have an object and this object is moving, say this object, you applied a force on the object and the object is moving with certain speed. The mass of object is there and the object start to move with certain velocity. So what we call as the object is moving, we call that as momentum. But you have an object which is fixed from one end, so object is fixed from one end, and you applied a force and you observe that the object is rotating either clockwise or anti-clockwise, you call that as moment. So the turning effect of the force, whenever force applied and object rotates, we call moment. So if you want to calculate the moment or the turning effect of the force, it's always force multiplied by perpendicular distance from the pivot. So example, an object which is fixed from one end. This is a point around which the object is fixed. Object can rotate. And you're applying a force of 30 Newton. So you applied a force of 30 Newton, and the distance from the point where the object is fixed to the point where you're applying a force, this distance is equals to, example, 5 meter. And the question is calculate the moment, the turning effect. So how you can calculate the moment? The moment is calculated by force multiplied by perpendicular distance from pivot to force. So if you want to calculate a moment, the simple formula is force multiplied by perpendicular distance from pivot to force. So force, it's given here 30 multiplied by perpendicular distance from the pivot. What is the distance from the pivot to the point where we are applying the force? So this point is a pivot because the object can rotate about this point. So 30 multiplied by 5, so 3 multiplied by 5 is 15. So it will be 150. What is the unit of the force? The unit of the force is Newton. And what is the unit of distance given in the question? It's meter. So it is 150 Newton meter. But one thing is missing here, because moment is a vector quantity. So we have to specify a direction. Which direction this object will rotate? Clockwise or anti-clockwise? Which direction this object will rotate? So the object will rotate clockwise. Is it clear the concept of the moment? When you apply force and the object rotate, you call that as a moment. How to calculate the moment? It is a force multiplied by perpendicular distance from pivot to the force or point of action of the force. Another example, so you have a box and you place a stone in front of this box. The dimensions, the size of the box is given. This is example 5 meters. And this one is 3 meters. And I'm applying a force on this object. A force of 100 Newton is applied. So this is a point around which the object can rotate. So what is a pivot? This point is a pivot because object can rotate around this point. The unit of the moment depends on the unit of length. Unit of force is Newton. If unit of distance is meter, then it will be Newton meter, or it can be Newton centimeter. Both units are acceptable. So if I want to calculate the moment here, so moment is force multiplied by perpendicular distance. This point is a pivot. So what is the force? The force is given 100. But what is the perpendicular distance between the pivot and the force? 5 meter or 3 meters? What is the perpendicular distance or 90-degree distance from pivot to the point where we applied the force?
3 meters.
The SI unit of moment is Newton meter, but other unit can be Newton centimeter. So the distance from the pivot to the point where we are applying a force, the 90-degree distance is 3 meter. So we always take a 90-degree distance between the pivot and the force. So if we calculate a moment, so in this case, the moment is equals to force, which is 100, multiplied by distance from the pivot, it's given 3. Perpendicular distance from, so 100 multiplied by 3, that's equal to 300 Newton meter. If distance is in meter, then it will be Newton meter. If distance is in centimeter, it will be Newton centimeter. Is it clear? So we always take the 90-degree or the perpendicular distance from the pivot. Another example, if I say an object of length 5 meters and the weight of the object is acting at the center, this is a pivot. And the weight of the object is 20 Newton acting down. So how we can calculate the moment in this example? Because moment is a product of force multiplied by perpendicular distance from pivot to force. So force here, what is the force given? The force is 20. But what about the distance here? Distance from the pivot. 5 is the total distance. But we take a distance from the pivot. So what distance we need, because the weight of this object is acting at the center. So what distance we will consider? We'll take 2.5. So in this case, when I calculate a moment, it will be 20 multiplied by 2.5. So 20 multiplied by 2.5, which is equals to 50 Newton meter. Because the weight of an object is acting at the center. If total length is 5 meter, then half of the length will be 2.5 meters. But which distance we take? We always take a distance from the pivot to the force. So force is applied from this point. So distance between the force and the pivot is 2.5, not 5. That's why we are taking 2.5. Is it clear the concept of the moment or the turning effect? We applied a force and the object rotate. We call that as moment. Moment can be clockwise or it can be anti-clockwise. To calculate the moment, the force multiplied by distance from the pivot, we calculate the moment. And what is the direction of this? Because the force is applied, so which direction this cause a rotation? This will be clockwise. So it's 50 Newton meter clockwise. So if you want to increase the moment, so what we should do, so we should increase the higher force. So if we apply more force, then the moment will also increase. So you have two objects of same size. The length of first object is equals to 2 meters. Length of the second object is also 2 meters. An object is fixed from one end. Object can rotate about the point. The point around which the object can rotate, we call that as pivot. Now, if I apply a force of 100 Newton and apply a force of 200 Newtons, which one will produce a greater turning effect? A or B? Which one is having a greater turning effect? So B will have a greater turning effect or greater moment, and how you can calculate? So it's 100 multiplied by 2. You will get 200 Newton meter. And which direction this will rotate? This will rotate like the clock. So that's why it is clockwise. You apply 200 Newton at a distance of 2 meters. So moment will be 200 multiplied by 2. That's equal to 400 Newton meter. Also, it is same as direction of the clock. So clockwise. So which one is producing a greater turning effect or greater moment? So B is having a greater turning effect or greater moment. So if you want to increase the turning effect, you should increase the force. This is one thing. The second one, so by applying a higher force, we can increase the moment. Or what else we can do? We can increase the perpendicular distance. So if you have an object of length 2 meters, this is a pivot. The length of this object is 2 meters, identical objects. I'm applying a force of 50 Newton at the center, and I'm applying a force of 50 Newton at the edge. which one will produce a greater turning effect or greater moment, A or B? Which of them will have a greater turning effect or greater moment? So again, B will have a greater moment or greater turning effect because the distance from the pivot, when we calculate the moment for A, it's 250 multiplied by not 2, because 2 is the total distance, but we take a distance from the pivot. So distance from the pivot is 1. So it will be 50 multiplied by 1, which is equals to 50 Newton meter. But for B, the distance from the pivot is the total distance, so it will be 50 multiplied by 2, which is equals to 100 Newton meter. So B is producing a greater turning effect than A. That's why. So if we want to increase the turning effect, we should increase the perpendicular distance, or we should apply a greater force to have a greater turning effect. Any doubt in this? A boy loses a nut using a 0.5 0.25 meter long spanner. He applied a force of 50 Newton on the spanner. Calculate the moment of the force. So how the figure is not given. If figure is not given, you cannot mention a direction, or you cannot say clockwise or anti-clockwise. So what will be the moment here? So force is given 50, and the distance from the pivot, is 0.25. So force multiplied by distance, you will get 12.5 Newton meters. Sometime what happen when we apply a force on the object, like if two moments are acting in the same direction, how to get the resultant moment? So if moments are acting in same direction, we will add. Or if the moments are acting in opposite direction, we will subtract. Yes, when they ask, it's better you mention the direction. Otherwise, if you are not mentioning a direction, it's okay, acceptable. So if moments are acting in the same direction, we will add to get the resultant moment. If they're acting in opposite direction, we will subtract. So if I say a plank, a wooden plank, which is fixed from point A. So point A is a pivot. The length of this plank is 6 meters. And you're applying two forces. There are two forces acting on this plank. Number one, the force of 30 newtons and another force of say 50 newtons. And a force of 30 newton is acting at a distance of 2.5 meters. So two forces are there acting in the same direction here. And the question is calculate the resultant moment. So if I want to calculate the resultant moment, how we can calculate this resultant moment? So moment is a product of force and distance. So first thing, we will calculate the moment for each. What is the moment caused by this force? So it's 30 is the force and distance is 2.5. So if I say force 1, this is force 1 and this one is force 2. So moment of force 1 so moment of F1, it's force multiplied by distance. So force is given in the question. So it's 30 multiplied by 2.5. So 30 multiplied by 2.5. What is the result? So it will be 75 Newton meter. And if I want to calculate moment of F2, that's equal to force multiplied by distance. So force is 50 and the distance from the pivot is given 6. So 50 multiplied by 6, it is equal to 300 Newton meters. What is the direction of moment due to F1? What is the direction of the moment due to force 1? Which direction force 1 is causing a moment? Yeah, both of the force 1 is causing a clockwise, force 2 is also causing a clockwise. So this is clockwise, the second one is also clockwise. What is the resultant moment? Result or the sum of final or the net moment? So I told you if moments are acting in same direction to get the result, we will add. So both moments are in the same direction to get the resultant. We will add them. So 300 plus 75. So the resultant moment is equals to 375. Newton meter. Is it clear how to calculate the resultant moment? Any doubt in this? How is 375? Because the moment due to first force is 75, which is clockwise, and moment due to the second force is equals to 300, that is also clockwise. So if the two moments are acting in the same direction, to get the result we will add. That's why 300 plus 75 or 75 plus 300, it will give 375. Is it clear? This example. Take the screenshot, then I will move on and give another example. The same question, if I just change the arrow, the direction, and what is the resultant moment? Because resultant moment clockwise and clockwise, so resultant moment is also clockwise. But if I change the direction of one of the force, a 30 Newton force, now it is acting up. So as the 30 Newton force is acting up, which direction? This is causing a moment now. The 30 Newton force is causing an anti-clockwise moment. So if 30 Newton force is causing an anti-clockwise moment, and that is 75 Newton meter, and 50 Newton force is causing a clockwise moment, that is 300 Newton meter. If I want to find the result, how I can find the resultant moment? So I will simply subtract them. And the direction of the resultant moment is always the direction of the greatest moment, the moment which is having the highest value. That is why it will be clockwise. Is it clear? The second example of the moment, if moments are in the same direction, because it's a vector quantity, we will add. If moments are in opposite direction, we will subtract. If the question was what is the resultant force, not about moment, resultant force. So how you'll identify the resultant force? You can see a 50 Newton is acting down. In this example, 50 Newton is acting down and 30 Newton is acting up. What is the resultant force? Not moment, force. So 50 is acting up, 30 is acting down. Sorry, 50 is acting down and 30 is acting up. So when you calculate the resultant force will be 50 minus 30, which is equals to 20 downwards. Is it clear? The concept of the moment, the turning effect.